Imagine a visitor from another star system that's firing a jet of gas not away from the sun, but directly toward it. And as it does, it's releasing a refined metal alloy into space, a compound on Earth that's almost exclusively produced in factories. Far from Earth, something remarkable is happening. The interstellar object 3I Atlas is emitting a metal alloy never before seen in nature. This is a refined compound normally produced only through human industry. Observations from multiple telescopes, including the Hubble and James Webb Space Telescopes, also show an unusual sunward jet, which contradicts what's normally expected from comet behavior. These findings are fueling a growing scientific debate about its origin and composition. In this video, we'll break down what was discovered, why it matters, and what future observations could reveal. It all began in July 2025, when astronomers detected the interstellar object 3I Atlas on a hyperbolic path through our solar system. A hyperbolic path means an object is moving fast enough to escape the sun's gravity, a sure sign that it came from outside our system. Atlas quickly stood out for its massive size, unusual chemical emissions, and distinctive activity. By August, observations from the Keck Observatory revealed something never before recorded in space. Atlas was emitting around 4 grams of nickel per second, but with no detectable iron. This is a serious departure from what's seen in other comets, where nickel and iron are always found together in similar amounts. Further analysis identified the compound as nickel tetracarbonyl, a refined substance known on Earth only from industrial processes like aerospace coatings and specialized metallurgical manufacturing. Detecting this molecule around a natural object is unprecedented. At the same time, Atlas displays another anomaly. It lacks a typical cometary tail. Instead, a jet of material is pointing directly toward the sun. This isn't an optical illusion caused by perspective. Multiple instruments have confirmed its orientation. The jet consists mainly of carbon dioxide and water, with trace amounts of cyanide and nickel compounds, but again, no iron, reinforcing the chemical oddity. Adding to the puzzle, Atlas has a carbon dioxide, CO2 to water, H2O ratio of about 8:1, which is among the highest ever observed for such objects. Furthermore, polarization measurements show an extremely negative value. This technical term simply means that the dust grains on its surface scatter light in a way unlike any familiar comet, suggesting its surface structure is also unusual. At the heart of the debate surrounding 3I Atlas is the detection of nickel tetracarbonyl. This compound doesn't form naturally under the conditions we observe elsewhere in space. The prevailing interpretation is that Atlas is a natural object formed under exotic conditions. One hypothesis suggests it originated near a carbon dioxide ice line in its home system, a region where the distribution of iron and nickel might differ from our solar system. Over millions of years, exposure to interstellar radiation could have selectively altered its composition, allowing nickel to escape as a gas, while iron remained bound in the nucleus. A more provocative alternative hypothesis is being put forward by some scientists. They argue that the combination of a sunward jet, refined metal emissions, and precise orbital characteristics is difficult to explain through natural processes alone. For this reason, they raise the possibility that the alloy could be a technosignature, a clue pointing to an unnatural origin. However, most of the scientific community remains cautious. As the saying goes, extraordinary claims require extraordinary evidence, and the current data, while unusual, is not conclusive enough to make such a leap. The sunward jet adds another layer of complexity to the mystery. Normally, the solar wind pushes gas and dust away from the sun, forming the familiar cometary tail. Atlas defies this rule by streaming material toward the sun. Researchers are now investigating whether the composition or the grain size of the ejected material could explain this reverse dynamic. Regardless of its origin, Atlas has already delivered significant consequences for planetary science. It provides direct evidence of material from another star system that doesn't align with our known chemical models. Nickel without iron challenges our assumptions about how metals are distributed during planetary formation. So far, every interstellar visitor we've observed has behaved differently. Oumuamua accelerated without a visible tail, while Borisov resembled a typical comet. Atlas is massive, chemically anomalous, and dynamically unconventional. This diversity suggests that interstellar space is populated not by one type of object, but by a broad spectrum of bodies, each carrying the chemical signature of its home system. Looking ahead, several key developments are expected. High-resolution images from the Mars Reconnaissance Orbiter should provide critical insights into the jet's structure and surface properties. Continued observations from Keck, JWST, and other telescopes will refine measurements of the nickel emissions and track how the jet evolves with its distance from the Sun. Soon, the Vera Rubin Observatory will increase the detection rate of interstellar visitors, giving us a larger dataset to compare with Atlas. In conclusion, 3I Atlas has defied expectations with its strange jet, metal emissions, and chemistry unlike any known comet. Whatever its origin, it's already reshaping how scientists study interstellar objects. The next observations may not just explain Atlas, they could redefine what we think is possible in deep space.